Hello again. Good morning, good day, good afternoon, good evening, good night, wherever you are in the world, and welcome to another stream here in Freaky Physics. Today we have a student. We're gonna have who do we have today? We have Ariana, and I'm gonna join the lesson now. Hopefully, she's already there. We're doing math, but I don't know the topic exactly yet. But of course, just as usual, we're ready to tackle that topic head on. So let's just join. She's here. So hold on. Morning,
Hello.
Ariana. Hello. How are you today?
I'm good. I'm a little sick though, so
Hope it's not serious.
yeah. It might be just allergies because I went to a friend's house with cats.
Oh, I see. Yeah, most likely then. Well, hopefully
Like,
it's just that. All right,
yeah.
so what are we doing today then?
Um. Hold on. Oh shoot. I can actually send some photos. I think.
Sure, go ahead.
Sorry, I didn't do that earlier. I passed out once I got home.
Yeah, I understand. Don't worry about it. If you're sick, right? So yeah,
Yep.
we can do it now, so it's fine. All right.
So how's your day been?
Well, it's my birthday today.
Oh, it is. Happy
Yeah, thank you.
birthday.
Thank you. And well, when there comes a time, I think your parents would have said the same thing, or your any grown up would say the same thing. There comes a time wherein you just don't care about your birthday anymore, except the big ones. It's not one of the big ones
Hmm.
right now,
Ah. Okay.
but it's fine. It's still a fun day. No, yeah, I just had a little celebration here with my family. That's it.
Aw. That's nice.
Yeah. All right. So, have you sent anything yet?
I'm about to send something. It's just
All right.
gonna take a really quick. Okay.
Yeah. Okay, got it. I'll just wait for it.
All right. Sorry, I just.
Yeah, it's okay. Don't worry about it. I mean, if I were sick, if I was still studying and I was sick, yeah, I would do the exact same thing. I'd rather rest than do anything.
Yeah.
Uh-huh. So yeah, totally understandable. All right. So while we're waiting, let me just set up the board then.
All right. Continuing on the same board.
Right? Yes, we are. I'll just send the link again.
Mhm. Mhm.
Mm-hmm. It's still about trigonometry, right?
Yes.
Yeah. All right.
It's like this thing with amplitude.
Oh, okay. So you're basically rotating your unit circle. Interesting. Right. Okay,
Yeah.
I got
I'm
it.
kind of confused.
Yeah, I got it, and it's just loading. So give me a few moments to load it up.
All right.
Right. Okay. Okay, it's almost ready. Give me just another few seconds here, I guess.
Mhm.
Okay. I think there's something wrong with my internet. I think it's a bit slow right now.
Ah.
Yeah.
Okay.
Hold on. So So while I'm waiting for the PDF to load, would you mind sending like the screenshot of the first few pages? Maybe the first page?
All right. Nice. Snip tool. Oh shoot, one of them sideways. Hold on.
Mhm.
I put it on the board.
All right. Yeah, I can see your cursor there.
And those were like practice problems.
I see. Okay. Um, oh, okay, I get it. I get it now. All right. So the idea here, um, let's move that out. Let's move that around. Yeah.
Hmm.
Okay. Um, so what you did here basically is you graphed the sine of the angle on and versus its actual angle. Angles on the x-axis, then the sine of the angles on the y-axis, right? Okay.
Hmm.
So here's the key idea here. You can change your trigonometric function, but basically this is how a sine function always looks like. Okay. So
Hmm.
this is the sine of let's use theta here. Should be equal to um f of x. F of x equals sine x. Okay.
Hmm.
Again, this is always how it looks like. There are a few properties to this. Okay.
Hmm.
So f of x equals sine of x. Okay, I see the other one you're pasting. Go
Hmm.
ahead, just resize that real quick.
Yeah, that's what I'm doing.
Mm-hmm. Okay. Mind if I see if I look at what you're doing right there? Yeah. Okay. Yeah, okay, this is nice because from what you're showing me here, this is exactly how I would approach this particular topic anyway. Instead of telling you what the rules
Hmm.
are, we figure out what the rules are, right?
Hmm.
Okay, so now that we have the graph of sine x, let's kind of go through this bit by bit. All right, I think I'll move it down. Yeah,
Hmm.
I'll move it here, and then I'll move this other one there.
Hmm.
Okay, I'll just move this last one here down again. Yeah.
Okay.
All right, now, um, okay. So how do you understand all of these things you've done in your notes? Like, what don't you understand? Let's just go straight to that.
How to graph it? I'm a bit confused on the graphing part.
Oh, okay. But once actually calculating the value shouldn't be too much of an issue, right?
It's not that part is not too hard, but like
Mm-hmm.
I think domain and range and like
Right.
graphing it, I'm like a little like, oh, what do I
Okay.
do?
All right. So what we'll do here, because it's not obvious from these values, right?
Mhm.
Okay. Now, if you look at this, remember that these things are related to the unit circle. So we'll go back to that idea. Yeah.
Mhm.
So in the unit circle, hold on. Oops, sorry. My board just locked itself out. All right. So unit circle. Okay, it's not working like that. I better just do this. Okay. Now, in the unit circle, remember that if this is your y and then this is your x, and then you have your circle here with radius 1, right? This is
Mhm.
1. And then we're going to look at this point, x and y, right?
Mhm.
Okay. Remember here that, let's also make that angle theta here, right? We have established before that um, y is equal to sine of theta, and then x is equal to cosine of theta, right?
Mhm.
We've established this before. And look at this. What is the, okay, just by looking at that circle, what are the possible values of y? What's the minimum possible value for y, and what's the maximum possible value for y? Same thing for x,
Mhm.
okay? So if we look here, I'm going to use black now for y, okay? This is your negative, this is your minimum value, and that's your maximum value. So
Yeah.
minimum y and maximum y. We cannot get any bigger than that. Similarly, this would be your minimum x, right? And this
Mhm.
is your maximum x.
Mhm.
Okay, you will notice that they have the same values. So the minimum value here is equal to what? -1. It's this thing, right?
Mhm.
And then the maximum
And
value,
maximum
go ahead.
one.
Yeah, correct.
One.
1. So similarly for x, um, what's the minimum value here? It's also -1.
-1.
And then what's the maximum value?
One.
1. Okay. So you will see that for both the sine and the cosine function. So let's say now that f of theta is equal to sine theta. And then here, g of theta equals cosine theta. We're going to focus on f because that's the examples given to you here. That's what you've basically done, right? But these
Mhm.
properties also apply to cosine. So we again we'll
Mhm.
focus on sine, but the properties will mostly apply for cosine as well. Okay. Now, um, okay, so that's the first thing. So we can now establish that for both of these, the range is from -1 to 1. I'm not gonna write it like that. The range is gonna be theta, sorry, not f of theta, right?
Mhm.
F of theta, the range would be between -1 and 1. So -1 here and greater less than or equal to 1. So this is
Mhm.
why. So if we go back to your values from the ones you calculated earlier, this explains why your maximum possible value here is 1. So if let's zoom in there, okay? So you see here that whatever you do, your maximum value for the sine of x is 1. It's here,
Mhm.
-1, +1, -1. So that's why the range here, and it's yeah. So the range here,
It's kind of like the unit circle, like
mhm,
the axes.
yes, exactly, right? Because these values, let's zoom back out first. You know what? I just realized something. Zoom out doesn't make sense as a phrase, right?
Yeah, because it's like supposed to be like in. Uh,
Yeah. Anyway, yeah, we're stuck with that phrase now. Anyway, if you here's the idea. This is the unit circle. What you're basically doing, and here's the uh basically what you're gonna do is you're gonna each time you rotate your unit circle, you change your angle, right? So what you're doing
mhm.
here is you're now changing the theta here, and then this is your sine. Basically, this is just the value of y. Okay, so
Mhm.
what you're doing here is you're increasing this x, and you're looking for this value of y, and that's equal to sine theta. Okay, that's why I really started with the unit circle because you can convert the unit circle into this graph. And in order for you to do that, you follow what you just did here. This is what
Mhm.
you're doing. So, and then there. And since it's just sine theta, and we know that the range of sine theta is just going to be negative 1 to 1, that means that your maximum and minimum values for whatever this graph looks like is going to be negative or positive 1. Maximum
Mm.
1, negative 1 for minimum. Okay. Now, all sine waves will look more or less like this. You can stretch it out a bit, you can shift it a little bit to the left and right, up or down, but they always look like this. Okay. Similarly,
Mhm.
cosine function will also look a little bit different than this, but it's quite similar as well. Okay.
Mhm.
So I'll just show you how cosine looks like. Cosine would look like this. I should use different color. Let's use pink. So cosine would look like this. Okay.
Ah.
You see, it starts at a different point, but it's
I
but
think I have it on one of the other paper too.
okay. So something like this. So
Mhm.
it's like lagging behind, right? Is it lagging
Yeah.
behind? Yeah, it's lag. No, it's ahead.
Oh.
Well, it is lagging behind. Okay, sorry, it is lagging behind. But the idea
Mhm.
here is either the sine or the cosine function will look the same way if they're just gonna be shifted one way or another relative to each other. Okay, sine of
Mhm.
x. Okay. So now that we've done the domain and sorry the range, we're clear with how the range is, right? The range
Mhm.
basically again comes from the fact that we use the unit circle. Now, we will use the unit circle again to determine the domain because the domain here in this case becomes the angle theta, right?
Mhm.
So if you look here, let's go back to our unit circle. If you think about it this way, and I'm going to use the finer line here, you will see that you can go once around the circle and then you can go around again and again and again and again to an infinite number of times, right?
Yeah.
Okay. So similarly, you can go the other way around. You can go clockwise and you can go this way one, two times, three times, four times, and so on, an infinite number of times again, right?
Mhm.
So this means in your graph, when you're shifting from the unit circle into the sine theta graph versus theta, what you're basically saying is your theta can take on any value. Okay, so this is why can it take again on on any value? Because you can just keep rotating infinitely
Forever and ever.
forever and ever. So what's gonna happen here? This means the domain is um negative infinity to infinity. Sorry, not domain. Oh yeah, it is a domain. So the domain is negative infinity to infinity, and the range is from negative 1 to 1. That's going to be true for the sine function and the cosine function.
Mm.
Okay. So is that clear now on why okay, is that clear now? The part that you don't quite get. Clear?
Kinda. Yeah.
Kinda. Okay. So it's good. Now, whenever you have the sine or cosine function again, you didn't do tangent yet, right? And I think you did mostly
Um.
sine.
We were shown tangent. Yeah.
Mm-hmm. Yeah, I see it. You were shown tangent here, right?
Mhm.
Let's take a look at that later. But for sine and cosine, again, since they're really similar, we're just gonna look at the sine function for now. The cosine function.
Okay.
Okay. So let's take a look here. When you add 2 to the sine function like what you've done here, okay? Like what you've
Mhm.
here in the thing, right? So you're
Mm.
adding whatever this value is, you're adding 2 to it, right? So
Oh.
that's why if you're adding it outside of the function, so I'm going to write it like that, you're shifting it up 2, okay?
Mhm.
Now, if you're put again, this is because you're basically adding 2 to the y, right? But
Mm.
here you're adding the 2 to the x.
Mm.
So that's why it goes to the left by 2, okay?
Oh.
Okay. Uh okay. I'm going to show you an example of Okay, never mind that first. One thing, the word amplitude I see here. Okay, do you understand these two terms, the amplitude and the period?
A bit, kind of.
Okay, can you explain to me how you understand these two words? Amplitude versus period. So what's the
It's like
okay, go ahead.
amplitude is kind of like I don't know. It's like how much it like. Oh shoot! I have a certain brush on.
Okay.
Is it kind of like how much it like goes like this on a graph,
Mm-hmm.
like the height
Okay, okay.
and.
Yeah, yeah, exactly. In mathematics, this is what we call the maximum displacement.
Mhm.
Okay, in mathematics. But of course, the way you described it is exactly what the amplitude is. Okay, so if you have a wave, let's keep this on the x-axis for now, right? I'm not gonna do the
Mhm.
y-axis just yet. So this is your amplitude. This is also your amplitude. Okay, all of these would be amplitude. Okay. Now the period.
Mhm.
How about the period? How do you understand that?
The period
Mm-hmm.
isn't that like 36 divided by like the number next to sine or cosine?
Okay. Now here's the idea. I'm going to just refer back to your original graph. Which graph shall I
Mhm.
refer to? Let's refer to this graph again. Yeah. Now I'm gonna
Yeah.
tell you this much that the period of this graph. Okay. The period of this graph here is 360.
Mhm.
Or are you supposed to express this in okay? Yeah, hold on. Yeah, the amplitude sorry, the period of this is 360 degrees. I see that in your examples you're using degrees and you're also using radians, right? So
Yeah.
in this case, let's so the period let me just define that first, okay? To make it easier to understand. The period is basically um the value of x or delta x, okay? So that uh, a complete wave is formed. Complete cycle is uh, is done. Okay. So
Mhm.
in other words, I'm going to go back here to this thing, and I'm going to just do this for now, right? It's not perfect, but again, the way you do it is you look at a particular point on the wave, right?
Mhm.
And then you look for one complete cycle, and that's gonna be here. That's gonna be you're repeating the wave from here on out, right? This is
Mhm.
your delta x, and this is your period.
Mhm.
Okay, and that's equal to your period. That's it's that simple. Okay, so for
Okay.
example, let's make this a bit um easy now. Now let's say that we have this sine wave that looks like this, and then this is x. You know what? I don't like that particular wave. Okay, let's say that this
Oh.
is. Let's make it easy first. Let's say that this is um x equals 5. So, so what's the period?
Um.
Remember, this is x in degrees, right?
Mhm.
So what's a period equal to?
You would divide it by 360 divided by 5.
Not quite, okay?
Oh.
Not quite. The answer here is that the period here is 5 degrees. If we want it
Oh.
in
Okay.
degrees, okay? Now, if you
Mhm.
want to change it to radians, if you want to change this to radians, this is going to be equal to 5 degrees times, and this, okay? Now, you may be confused.
Mhm.
That's what you do. You always multiply it by a factor that's of 2 pi over 360 if you have degrees. Okay? So if we
Mhm.
do that, that's gonna be okay, let's put the calculator in. And what's the value there? What is 360 divided by 5? That's gonna be 72 degrees, right? So
Hmm.
72. And then the 72 by 2 is gonna be, that's gonna be 36, right? So
Uh-huh.
that's gonna be pi over 36 radians.
Hmm.
Okay. Now, you may be wondering why 2 pi over 360, right?
Mhm.
Okay. The reason is simple. If you have a circle and you go one full rotation around it, that's 360 degrees, right? Equals one
Yeah.
rotation. But also, you can think of it in radians. One rotation is equal to 2 pi radians, right?
Mhm.
Now, I'm just going to put the radians like that in bracket because we're not going to use that particular unit, okay? So basically, the idea here is 360 degrees is equal to 2 pi radians.
Hmm.
Again, I write the radians here. So in other words, 360 degrees over 1 over 2 pi is basically just equal to 1 radian.
Mhm.
Okay, so that's where the conversion of 360 over 2 pi or pi over 260 is taken. Okay,
Hmm.
all right. So that's sine, that's cosine. Let's do the last one, which is tangent. And if we go to your notes, oh, before we go there, so the shifting parts, again, I think this one's pretty straightforward once you know how it's done, right?
Mhm.
Amplitude, period, done. Cosine is basically just sine. Let's do this one, the tangent function. Why is it zero,
Engine.
undefined, zero, zero, undefined, zero, undefined, right? You always get these values.
Mhm.
Now, the reason,
Yeah.
okay, did you just calculate this? Well, did you just write these use and solve for the values using a calculator? I think you did.
Um, I kind of just when we were doing the notes, I kind of just remembered like we made like a little chart that was kind
Mm-hmm.
of like tangent was undefined
At these certain
um
values.
with the y-axis.
Okay. Now, why is that the case? Remember that tangent theta, um, in trigonometric terms, not in SOHCAHTOA terms, in trigonometry, it's going to be that tangent theta is equal to sine theta, sine over cosine. Okay.
Mhm.
Now, in other words, if sine theta equals 0, tangent theta equals 0, right?
Mhm.
Now, if cosine theta equals 0, tangent theta is undefined.
Hmm.
Okay, this is the reason why we have these table of values here. Okay, so if you do this now, if you put this here now, it will all make sense if you write sine and cosine here now. So I'll just do that right here. So that's what's sine theta here and what's cosine theta here. Okay,
Mhm.
so and then if we put 0 here, what's the sign of what's sign of 0? That's gonna be 0 here, right?
Yeah.
Okay,
0.
and then cosine theta would be 1.
Mhm.
Right? And then, okay, I now know the pattern. I'm just going to show you right away. This is going to be 1 for sine theta, 0 for cosine theta. And then it
Mhm.
just repeats 0, 1, 1, 0, 0, 1, 1, 0, 0, and
Are there
1.
also negatives?
Yeah, there are negatives. I forgot the negatives. But which ones would be negative? This one would be negative.
Yeah.
This one would be negative.
Yeah.
This is going to be positive, positive, negative, right?
Mhm. Yeah.
Okay. So what happens here is from 0 to 90 degrees, you actually need to also do this. That's going to look like that.
Oh,
Okay.
forgot that one.
Yeah. But that's okay. That's okay. Now, if you do this, you will see that whenever you go from 0 to 90 degrees, it's positive here. And then from 180 going to 90, you go negative. right? Because of this. But whenever you
Mhm.
get to 90 degrees, or let's just highlight that 90 degrees, 270 degrees, 450 degrees, you're dividing by cosine theta equals 0, right?
Oh, that makes
Again,
sense.
that makes sense. That's why those are undefined for tangent theta at these angles. Okay.
Okay, okay.
And now because they're undefined, you can't really graph them. That's why you have these dotted lines.
Yeah.
Okay. Makes sense now, I hope.
Yeah.
All right. So again, if ever you get confused, just think of tangent as sine over cosine, and then cosine will be 0. When cosine is 0, tangent theta is undefined. Okay. And
Mhm.
what are those angles wherein you have cosine theta equals 0? It's 90, 270, 450, and
50. Yeah.
everything else in
Like
between. Yeah.
every other one.
Every other angle, every other 90-degree angle, so to speak. Okay.
Mhm.
Um, so yeah, that's basically it. That's how tangent would look like. And again, it's the same
Mhm.
thing. Think about it this way. This doesn't have a the amplitude here is NA, as you mentioned here, right?
Yeah.
Okay. Why is it NA? Because your amplitude, it just keeps getting higher and higher. It can reach up to
Yeah.
infinity, right? Like
Mhm.
Buzz Lightyear.
Infinity and beyond.
Yeah.
And my friend made that joke when she was talking about that.
Okay. All right. So this goes on to infinity. So going back. So that's why, because it goes to infinity, there is no maximum value. No
Mhm.
max value. And therefore the amplitude is not available. Okay. How about the period? Is there a period here?
Um, I think so.
Okay, what do you think the period is?
Hmm.
What's the period here? Just in terms of the angle first, just in terms of degrees.
In
Think about it.
degrees.
Yeah, think about it this way. The idea for period is there's a repeating pattern.
Mhm.
Okay, you see, is there a repeating pattern? There is, right?
Yeah.
Okay, so how long is that time for that repeating pattern, or that value of x for that repeating pattern?
Every 90.
Every 90. It's from here. It's not 90.
Oh.
It's from here to here, right?
Mhm.
That's basically, so you know that this is 90 degrees and this is
Mhm.
270 degrees. So the period is
270.
270 minus 90.
Okay, hold on.
Okay. All right. I think you got lost there. So let's redo that.
Yeah.
Okay. So the period is equal to 270 degrees minus 90 degrees, right?
180?
And that's 180. Okay. Now, if we convert that to radians, what's that going to be? So again, we convert with 2 pi
Um,
and 360, right?
half a pi.
Mm-hmm. So that's going to be 180 times 180 degrees pi. Yep, 2 pi over 360. It's not half of pi.
Oh.
It's pi. That
Oh.
totally
Oh yeah.
cancels out, right?
Pi.
Pi. Okay, so pi radians. So this is your period in this
Mhm.
particular case, all right? So,
Mhm.
um, okay, what's this pi over b here? I'm just wondering what this is. But yeah,
Yeah.
generally speaking, once you see the patterns, just follow your notes for the actual periods, knowing certain properties of the formula. But this is why
Mhm.
these things are the way they are. Okay?
Yeah.
Okay. Clear?
Mhm.
All right. So let's take a look here on the last thing you pasted. All right. So here, let's take a look here on this graph. What is the let's answer the same questions for all of these. Even though you already wrote them here, right?
Mm-hmm.
Just what's the period here? What is the amplitude? Same thing, period
Okay.
amplitude. But let's this time instead of looking at the answer, let's reason out why you answer that.
Mm-hmm.
Okay.
So the 360 divided
Mm-hmm.
by x, I think
Mm-hmm.
that x an amp would be. I'm gonna sneeze.
Go ahead. Bless you.
Thank you.
The amplitude is correct. The amplitude is 2. Okay. The period is not 360 over x. Yes, it's sort of 360 over x, right?
Mm-hmm.
Uh
360 over what?
mm-hmm. Yes, over
Oh, okay.
1. Yes, okay. It's 360 over 1. Why? Because here, if you look here, that's basically, I'll just rewrite the whole thing. That's 2 sine of 1x. You're going to take the number and divide 360 by that number.
Mm-hmm.
Okay. So yeah, 360 over 1, that gives you 360 degrees. If you keep it in degrees, right?
Yeah.
And then this is 2,
2
correct?
pi.
Correct if you do that in radians. So these are correct. All right. So let's take a
Okay.
look. Let's take a look here now on the second graph. What is the period? So again, this time you're still gonna look at the same spots for cosine and sine. Still gonna look at these
Mm-hmm.
numbers here. Okay?
It's like 360 divided by 1/2, which is
Correct.
just 360 times 2, right?
Correct. All right, let's put
Equals
that here.
720.
Okay. Correct.
The amp is 1. It's not -1, right?
The amplitude is always a positive number.
Okay.
Okay.
1.
1. Okay. Now, one thing you can do with the amplitude, if you're given the graph, just let's take a look here, yeah? Given the
Mm-hmm.
graph, okay, you see this distance here? This is
Mm-hmm.
always equal to 2 times the amplitude.
Mm-hmm.
This is given the graph, okay? So 2 times the amplitude equals maximum y minus minimum y, okay?
Mm-hmm.
So that's one way. Now, where do you find this amplitude here in the equation? It's this coefficient as you've done, but
Yeah.
without the sign. So this is correct. That's 1. This is correct. 720. Right. Okay. Let's take a look at this last one for the tangent function here. What's the period?
Mm-hmm.
What's the amplitude?
Okay, so the period
Mm-hmm.
would be. This is 180 now this time,
Yes,
right?
this is
Because it's
180.
different from the. Yeah.
Mm-hmm. But
So it'd
so you
be.
don't do 360, you use 180, correct?
Okay. 180 divided by 45?
Why 45? Because of
This one.
yes. Okay.
That one.
Uh Actually, no,
No,
not
try.
divide by 45. Hold on, let me double check. No, it's not plus the 45. It's not of the plus 45. The
Oh.
answer here is the answer here is 180 over 1.
Oh.
Why? Because okay, because again you're looking at the coefficient with x. There's your 1 here.
Mm-hmm.
That's what you use. Okay?
Mm.
All right. So, okay. So that's why it's over 1. I think we'll go through
Mm-hmm.
the general case later since we still do have time. Okay. So,
Mm-hmm.
so there are many. Okay. So we're done with amplitude, period. Now we can do the shifting, right?
Mhm.
Okay. The shifting happens by okay, so basically it doesn't matter whether it's sine, cosine, or tangent in this case. Okay. So I'll do this one. So for sine, again, I'll just write sine. Okay.
Mhm.
I'm gonna do a x plus b. Okay. What else can I do? I can have c here.
Mhm.
Where else? And then plus d, right?
Mhm.
Okay. Um, okay, let's say that f of x is equal to this. C times sine of, I'm just gonna put that in bracket like that, right? Okay, so no need for the bracket. So what do these numbers do? I'll just put that like that. What do these numbers do? So
Mhm.
A, okay, A is the uh shifts the period.
Mhm.
Hold on, let me double check that. Yeah, shifts the period. Okay. C shifts the amplitude or changes the amplitude. Okay.
Mhm.
Actually, C is the actual amplitude. Okay.
Mhm.
What is B and D? B and D will shift um by shift X by negative B, right? Shift X by
Mhm.
negative B, and then D shifts um f of x by D. Okay. So
Mhm.
it means it moves it to the left here, and then this moves it up here, as you mentioned earlier. Okay.
Mhm.
So again, this will work with sine, cosine, or tangent.
Okay.
Okay. And of course, the only exception to this would be tangent. Tangent doesn't have an amplitude. But other than that, we're okay. Same ideas.
All right.
Okay. All right. Um, okay. So this time I'm gonna give you a function with no graphing needed. I'll just give you three functions: one sine, one cosine, one tangent. Okay.
Mhm.
So let's do this. F of x. The first one will be f of x equals 2 sine of 3x plus 4. Okay.
Okay.
All right. Then I'll just write the rest here. G of
Mhm.
x is equal to 1 half cosine of negative x minus 3. Okay. And then finally, let's do
Mhm.
h of x. That's going to be tangent. Negative 4 thirds tangent of 2x. Okay.
Mhm.
All right. So all of them, same thing. You find the period,
All right.
find the amplitude, find the shifts. Shift
Okay.
in x, okay? And then shift in y.
Okay. I don't think any of them have a shift in Y.
Mm-hmm.
The up and down.
Yeah.
No.
Again, okay, hold on. Let me show it to you again.
Press it out.
There. Okay. So again, A shifts the period or stretches or compresses the period. I'll just change this.
Mhm.
Stretches the period. Okay.
Okay.
Okay. C is the actual amplitude. You don't have to overthink that. It's just straight amplitude right away. Yeah. B
Mhm.
will shift X to the left by that amount, and D will
Mhm.
shift f of x by that amount upwards.
Mhm. Yeah. So I know the amp. I'm just gonna point to the amp.
Mm-hmm.
Amp.
I'll make it easy here.
Amp.
Period, amplitude, x
Oh.
shift,
Oh.
then f of x shift. Yeah.
Okay, thank you. This is
So same thing
2.
here. P A x shift f of x shift.
One. And then so 360
Mm-hmm.
divided by 3, which is like 12, I think. And that is for this one. Yeah.
Mm-hmm. Okay.
For the shift to the x, this would be for left, right?
Mm-hmm.
Yeah, I'm just gonna put for L. This would be 3L. This is
You know what? I'm
none.
not seeing anything of your writing yet. Oh, because you're doing it on the side. Okay, never mind. There we go.
Yeah.
Okay, good.
Oh, is it not? Is it not showing up?
Yeah, it's showing up now. Oh, there we go.
I guess it's
Anyway,
just kind of like delayed. It's a
yeah,
bit delayed.
yeah, but we're
And
good.
I don't think there's a shift to the up down
Mm-hmm. Okay,
0 all the way.
okay, all right. Uh, I'll I'll take the correct ones. Which one should I use? I'll use green. Yeah, this is
Okay.
correct. This is correct. 360 by this is correct. Uh,
Oh wait a second.
sure. Go ahead
Can
if you
I
wanna.
make an adjustment real quick?
Sure, sure.
4, 3.
Okay, I'm still gonna say this is incorrect.
Oh, okay.
You got okay. You have to be careful. Remember, the only ones with amplitudes are sine and cosine.
Oh. NA.
There we go. That's now correct. Okay, great. So this
And
is now
then
okay. You only have one period correct. Only one is correct.
okay, hold on. Because
So,
period you have to divide it by 180
for which one?
for the tan,
Correct.
it should be 90.
Okay, so this is now correct.
Mhm.
How about
And this
G?
one. Did I write 120 for all of them? Wait.
No.
Oh.
You yeah. Oh yeah. You
Oopsie.
wrote 120 for all of them. I don't know what
Oh
happened
no,
with.
I did that.
Okay, X shift is for
Negative 360. Or is it just 360?
this is correct. This is correct. X shift. Correct. Correct. Uh okay, correct. Okay, your X
Wait,
shift,
huh?
this X shift is incorrect.
Hey. It's right, right?
Mm-hmm. Correct. This is now correct. Okay.
Mm?
Negative. Now here's the thing. Periods and amplitudes are always positive values. So I'll just say this is
Mm.
correct. However, you remove the negative. Okay.
Mm.
All right. Great. Done.
Okay.
Okay. So everything makes sense and you can all do it properly now. So hopefully this
Yeah, I'm starting
sticks.
to understand it a bit more. Thank
Yeah.
you.
All right. So, okay. So right on time too. So, okay. Well, if you can still ask a few things before we end. Is there anything else you'd like to, you know, want to know here?
Can you maybe can I try and graph at least one of them, like at least the cosine or sine? Can I try
Okay.
graphing and then you?
Okay, go ahead. Graph the
Yeah.
sine. Graph the sine function.
Okay, I'm gonna do it on the left.
Okay, so I'm going to scoot over. There we go.
Um, So the amp is 2.
Uh-huh.
Okay, and the shift is 0. So,
Uh-huh. Correct.
and the amp is 2, so I should do 2 negative 2.
Correct.
Mhm.
Okay, correct. So what's gonna be the next thing? The period or the x shift? I would personally do the
Um.
period first.
Okay. The period. So would it be kind of Wait.
Mm. Okay, I think I'll show you a technique. Yeah.
Okay.
All right.
Yeah.
Technique here is you take the period. Step one is
Mhm.
okay. You take the period and divide that by 4.
Mhm.
Okay. So
Okay.
in this case, we're gonna do 120 divided by 4, and that's gonna give us 30 degrees, right?
30.
So that's gonna
Okay.
be
So make
so basically my markings would be 30 degrees apart like this. So this is, for example, for now 30,
okay.
60, and so on. Okay.
60, 90,
Mm-hmm.
120.
Now the next thing. Okay, so this
Mhm.
is step one, right? Then add the x shift.
Yep.
Add the x shift.
Mhm.
So what I would do is I won't really change my
X.
markings anymore. Our x shift is 4 degree, just 4,
Mhm.
right? So I'm actually just gonna write this as
Yep.
34, 64,
Oh.
94, and 124.
Oh. Okay. That makes more sense.
Okay, and of course I'm also gonna put that 4 here right there. Okay.
Yeah. 4. Okay.
Okay. Then now what are you gonna do? You're gonna now
I'm just gonna.
do your graph.
Oh wait. Shoot. Hold on. I did. No. I actually brought up a text box.
Yeah, I figured out how that happens. That happens when you like hover and click on one spot for a long time. You're gonna make a text box when you do
Oh.
that.
Okay.
So try not to hover and click. Click and hover rather.
You can see what I'm trying to do. It's
Mm-hmm.
fine. Like that.
Oh, okay. Oh, hold on. My mistake. It should be to the left, right? So not 34. Let me just redo everything. But it's still the same idea.
20.
Yeah. Should
Like
be
26.
this should be 26, and therefore this will be uh 56,
50,
86,
86.
and 100 is 16, right? And then its
Yeah.
equivalent point here would be -4, right?
Hmm.
So that's where you start graphing. But aside from that,
Okay.
yeah,
Oh, so wait. I would start from -4.
you start from -4.
Okay, and then I go here, and I graph with blue.
Mm-hmm. All right. After this, you do the sine of x. Yeah.
Okay.
Okay. Great. And then finally, just do the branch and done. Easy. Yeah.
Yeah.
All right. So again, step one is you get your period and divide by 4. This would be your ticks, right? This would be the
All right.
initial
Yeah.
ticks. Initial ticks. And then add the x shift. And then these would be the final ticks, right?
Mhm.
Or not final, useful ticks. Ticks to use.
Mhm.
Okay, go ahead. Let's do the cosine function, g of x. Let's do it
Okay.
here. Okay.
I have to.
Okay. While you do that, I'm just gonna mark that this is for that, and then
So the M is half.
correct.
And it's 360. So 360 divided by 4 is 90.
Okay.
9. And then the shift is 3 to the, so it'd be 93.
Correct. 93.
183
Uh-huh.
to 73.
Uh-huh.
363.
Okay. And of course, don't forget to also put your X shift value itself onto the axis. So put
Yeah,
3. Yeah.
yeah. 3.
Uh-huh. Then this is cosine.
I'm gonna graph with. So I would start up
Not
here.
necessarily. You have a
Oh, I'm
negative
moving
for
the.
x, right? You have a negative on
Oh,
the
so I would
x.
start down here.
Yes.
And then move up. This. Boom.
Boom. Done. And then just if you want to
Okay.
extend it, just extend it. There we go. Done.
Yeah.
All right.
You. Thank
Great.
you.
So, okay, we're done then. So, good to know you understand this now. So, okay,
Yeah.
anything else before we end for today?
Nope. I think I'm good. I think I should just rest now.
Okay, yeah, I think so too. So, I'll see you next week and get well soon, okay?
Okay.
All right,
Bye.
bye now. All right, so that's the end of today's lesson and yep. All right, so that's basically it. So, with trigonometry, again, it's very easy once you know the initial patterns and how to actually find patterns in the data. Okay. Now, this is also so for those who are still wondering, so what's the use of math? I just want to end with this before we finish the stream. What's the use of math? You won't use it in everyday life anyway. You won't use sine, cosine, tangent. You won't use the imaginary numbers. You won't use whatever else you're learning in math, especially once after you graduate from school. Well, for most of you, of course, engineers will do it. Uh, computer engineers, computer designers, gaming designers. Of course, there are certain jobs that you would still need math for. But the main idea behind learning math, and I want to end it here, end with this, is that it makes you think. It's not this that's important. Because I'll be honest with you, if I haven't been teaching math or science, I would have forgotten most of this already. Okay? But I would not have forgotten the skills I learned, which is looking for patterns, uh, checking if my answers are right or wrong by verifying with data given. So again, mathematics, yes, it's useful as a tool, but for you as a student, it's going to be useful for you to develop critical thinking skills. Okay. And of course, the thing about critical thinking, once you know how to do it properly, you're gonna do it the rest of your life, and that should help you make better decisions eventually, even if it's not math related. Okay, so with that now, so yes, so that's the end of the stream then. So before we end, as usual, don't forget to like, share, and subscribe to the YouTube channel, the Facebook page, on Instagram, on TikTok, and on Twitch. So again, don't like to like, share, and subscribe. With that, again, I greet you all a good morning, good day, good afternoon, good evening, good night, wherever you are in the world. Stay freaky, everyone. Bye bye now.